In today's world, whenever you are using any application, either through your browser or through your mobile application, such as Netflix, Amazon Web Services, your emails through Google, Hotmail, or you're using your application for the banks, you are probably already using microservices. Hi, my name is Huram Hanif with Nano Integration Services. Today we will go over the architecture for microservices and traditional monolithic applications, and we'll compare them. In today's agenda, we will start with monolithic versus microservices architecture. Then we'll move on to agile and how organization can become fully agile using microservices architecture. And then we will finish off using containerization of microservices. There is a consensus in industry that for successful software development, we need to have three things in place: architecture, and then we need to have the processes such as agile, continuous delivery, and we need an organizational structure where we have the small autonomous teams, which are maybe from 6 to 8 developer at max, and they don't have dependency on each other, which will stop the teams to deliver the software in a timely manner. So let's start with the traditional monolithic application. We'll quickly go through this one because literally everyone knows about their architecture if you are in IT, or especially in software development. So these applications are layer and modular. They have a presentation layer. Probably they have model layer, controller layer like typical MVC. Other client application might be invoking web services deploy on this monolithic application, but not necessarily. Everything is packaged as a single AR or WAR file, which contains UI, controller, server-side logic, and this application typically connects to a database. These applications usually support two-phase transactions, which is great. And these are easy to support, and they have like a support for role-based implementation, such as if you are looking at having a role for a supervisor who have a higher limit, or who can override override authority, versus another simple user who has very basic CRUD operations, like they can create a client and they can update. So those role-based implementations, they are there, and there is no brainer because they can be implemented in a very easy way. So here is the and quick overview about the monolithic architecture. This is a sample application. Let's go through that. So it's a nano integration sales app, which is a monolithic app architecture. It has a UI choice. You can have a choice of framework implemented there. And then it has the modular implementation. For example, there are customer module, there is order module, there is product module, and this application is connecting to a database. And this application is hosted on a clustered environment. Now this is more or less a typical view of architecture for any monolithic application. So the advantages of monolithic architectures are like few of them I'm listing over here. Like they usually have a single code base, well-defined set of libraries. Programming language is typically the same for the whole application. And then development team, they have more or less the same skill set, and they are they can support each other. The build process is usually very mature because it's the same application. Every time the same build process happens, that goes through the testing cycle and whatnot. Then the documentation of those applications depend on if they are being implemented through Agile or the waterfall. Usually the documentation is quite comprehensive for those applications, and also well structured. The deployment is usually there's a set pattern for those development. So the build engineers will build the ER or jar files or the WAR files. They will provide it for the deployment. And then the different maybe operations team, they will pick it up. They need some kind of documentation, technical documentation for the deployment. And then they will there is a testing team. The testing team will do the testing for the application, and usually those practices also are also very mature, because this is an iterative approach, and every time there are changes, this goes through the testing cycle, and then it released to different environments, and that can be done either by the development team or the operations team based on what environment is being used for those deployment. That can be dev, Q environments, or the production or pre-production. So different teams will take different roles and deploy those applications. Once done, there is usually a smoke test, and they are released for production, the usage. So that's the advantage of monolithic applications. Okay, from today's perspective, there are some challenges for the monolithic architecture. So some of the points to consider are that usually they are large-scale code base, especially if the application is very successful at some mainstream application for the organization. So over the time, the code base will become very large, and it will have a lot of dependencies on different libraries, so it will be difficult to upgrade because of those dependencies for different libraries and modules. Not able to use uh, like fit for purpose language, programming language. For example, if we have a sales application and we have to incorporate, or let's take an example of a government application where government treats all the citizens, and they need to bring in some analytics into the application. To do that, the R language is maybe the best fit for purpose language, programming language to do so. But because the rest of the application is developed in Java, so it will be very difficult to use R language over there. So the different teams have to then look for the ways how they can incorporate that kind of implementation within the application. So code is usually interdependent because there is no clear division between the modules. So development teams tends to reuse the code developed by the other teams, and over the time, the dependency of the code will be quite complex. From testing perspective, the testing cycle is usually quite large because not only they tested the newly developed functionality, but also the regression is usually involved, which make it more test heavier from this perspective. It's not agile anymore because the agile teams usually they don't what when they are following the agile methodology, they don't create the design documents upfront, or they tend to not create, although they should. But there are different arguments about that one. But because they have a lot of interdependency, for example, if a team working on product, they need to change something in customer data, let's say table structure or something like that, then they have to work with the team responsible for the customers. And so there is a very heavy interdependencies on teams. And then it's not that if a team is done with their development, they can release that piece of code to production. They have dependency until all the agreed upon deliverables are in place, and only after the testing cycles are complete for all of those deliverables, then those changes can be moved into production. So that bring us to the last point of continuous delivery is a challenge. It's by nature. And it's very difficult to do the continuous delivery because of all the points which we just discussed. Okay, so let's discuss microservices based applications and what are the basic benefits of using microservice based applications. Those applications are usually comprised of different services. Each service represents a specific domain. UI or UIs are developed to invoke different services to support different operations. Thus, they are purpose-built. You can have one UI developed for the web browser, which is exposing more information for client or products or the orders. And then you can have another smaller version of the same application developed for the mobile application and which is displaying some information but not all. So it is very easy to develop whatever is required based on the requirements. API Gateway is used to manage, expose secure services deployed on a variety of hosts. These hosts could be in the public cloud or they can be in the private clouds. And the API gateway is the one where all the interaction will be taking place. We'll discuss that in short bit. Services can be changed and deployed quickly. That's the nature of those services. And this also enables organizations to be fully agile, which means that the agile team can deliver small chunk of promised functionality within a short span of time, which also brought us to autonomous teams. Because these teams are working on a code base which is for a specific domain, and this domain is being represented by this service, so those autonomous teams can deliver quickly. Okay, so let's have a look at microservices architecture. Um, so this is the decomposition of our sample nano integration sales app, which we saw earlier as a monolithic application. In this one, on the very right hand side, we can see there are three different databases: customer database, order, and product database. Then we have the microservices, customer service, then we have the order service and product service. Then we have the discovery service where all those services will register themselves. And then we have an API gateway which will enable the clients to communicate with the services. And then we have a separate deployment of Nano Integration Sales App UI that can be in Angular, React, or Spring Boot, whatever the technology of choice is. Then we have the client as a browser, then we have as a mobile application, or we could have other partner services which are acting as a client and interacting with our services using the API gateway. So this is a high level architecture how we can decompose our application in microservices architecture. The benefit of this could be, for example, if we have to scale this order service, let's say there is a big sales going on, then we need multiple instances of this order service. We can always spin more instances of this service, and this will be seamless with minimal efforts. Okay, so let's discuss the challenges of microservices architecture. Uh, the development, I would like to have them in three different categories as per se. Number one is the development complexity increase manifold. So holistic view needs a lot more documentation to make it right. The bigger your application is, the more microservices are there, the more documentation you need in order to provide a holistic overview, and so that everyone in the team is on board what's going on. Then API needs to be well documented. You can think of Swagger documentation, which will provide an overview of if we are using the REST APIs, then you'll probably like to use Swagger documentation so that all the request and all the response codes are documented properly. Next is the contract between services needs to be maintained and negotiated. Think of YAML file or so the development in the old simple word for the monolithic application was that you are going to probably expose some RPC and then you have corresponding POJOs and something in the UI to work with. So it's a very integrated project and you can start development both client and server side at the same time. No big deal. Whereas if for the microservices architecture, because these are probability is that they are different teams working on the microservices, so they have to have a very good contract discussed and finalized between different teams if there is parallel development going on. And one of the best ways to create YAML files ahead of time and then make them available both for the current version and the future versions, so that for the maintainability, the that those documentation or the contracts can be referred to. Next is the URL endpoint information needs to be maintained and it should be up to date. Any change needs to be updated in a timely manner, and the communication is required. This is also very important. So, for example, if you have, let's say, you have 100 of microservices, and you have at least five environments. So you need to maintain the URLs for all those 100 services for those five environments and all their corresponding endpoints, and you need to have the YAML information required, and the complexity will increase if there are further versioning available for all those services. So you can think of it's getting messier, but if proper documentation is in place and so the controls are in place, then instead of becoming a challenge, it might be a breeze for the development teams. um, Transaction support and error handling, because the nature of those services are they are running in their own VMs separately, not in the same transaction. So what will happen is that development teams will need to implement the transaction handling in such a way that if this is a distributed transaction and if there is any error, for example, if there is a timeout or any particular service is taking way too long, then you need to make sure that the proper error handling is in place, and also to recover from any failed state. For example, if there is a transaction which needs to perform three different tasks, and task one and task two is complete, and those are kind of transaction on the database level, whereas the third one is failed, then you need to make sure that you have a proper handling of this mechanism in place so that the third transaction can be completed and then the notification can be sent to a client or wherever is required. Then more processes needs to communicate with each other, complex environments. Again, as we discussed already a little bit about this one, that the boundary of transaction is not within let's say VM. It's in multiple VMs or probably across across the boundaries of even organization based on whatever is being implemented. So there is a lot more communication involved than there could be some SSL related issues or the communication related issues which we are going to discuss in the operational complexity. So that take us to the next column, testing complexity. So the testing team has less time to understand requirements and create test cases. Now, this goes back to the now our organization is fully agile. There are new stories from the backlog coming into the iteration, and those stories are being groomed and those stories are being implemented by the smaller teams. So the testing teams needs to be on top of their game to understand all the new requirements and the feature which are being developed, so that they can test as soon as those are available, or they can update their testing scripts if there is an automated testing involved. So test and the next one is the testing endpoints versus the end-to-end testing versus regression testing. So testing teams needs to create the boundaries of about their testing, like what exactly they are going to test. If there is a change in a microservice, then the scope of testing can be either just for that particular service, or it can be an integrated test with the in which in involve the UI, or it can be a full regression test based on whatever the scope is. So that needs to be well understood and implemented, so that quality code and quality applications can be deployed. The third one is the operational complexity. So SSL certificate management, nothing new as per se, but again, because there is a lot more communication happening between the services, so the SSL certificate needs to be managed in a proper way, so that there is no issue during the transactions, and there no expired certificates. And another thing is now this is a little bit gray area where that should reside. Should that be with the operational complexity, or should that be moved to development? But retirement of older version. So as soon as development teams are, run into, and it also depends on the organization. First, let me clarify this one. If there are multiple services running and there are multiple clients, especially if you have external clients who are invoking your services, then you might introduce different versions to satisfy the requirements of some clients, which will introduce versioning for the service level. Now, if you have multiple versions, you need to have a very clear understanding and very clear uh, published way of retiring those services, which means that you have a policy in place that if there is a new version available to the client, then the client should upgrade to that version within whatever time span you set, and then you can retire the older version of those service. Otherwise, you might run into the same challenges which we have seen with the monolithic applications. Okay, so let's discuss the advantages of microservice architecture. Um, First thing first is cross-functional teams. We have the autonomous teams who can make quick decisions because the application architecture help us to do so, and they can, because they are working on their own domain, so there is a guarantee that when they will make changes, they are not impacting other teams, which will help us this particular team for quick to market. And also this team can be an agile team. They can work on their own iteration and corresponding stories, and they can groom those stories into technical. They can do the technical breakdown for those stories without issues of communicating those back and forth with different teams, because in agile the iteration time is usually 2 weeks or 3 weeks based on which kind of agile teams you are working in. And if there is a lag time involved, there is a lot of communication involved with the other teams, then what will happen is that these stories, their scope cannot be finalized. Thus, that has direct impact on the iteration. And once there are a couple of such stories which cannot be finalized due to dependencies on different teams, then you cannot deliver them, in the first week or the second week. So your testing will be affected, and then overall your iterations will affect, which doesn't look so good for the teams. So but having microservices in place and when working on their own domain, then the teams don't have to worry about all those complexities. The next one is the scalability, support horizontal scaling. The horizontal scalability is the ability to increase capacity by connecting multiple hardware or software. So as we know that our services are already, either running in the containers, which we will discuss shortly. So, and it's very easy to spin multiple instances of those services based on the requirement. Either that's an auto scaling or whatever techniques are being used, but the basic architecture of the application does support that, so which make it very scalable. Programming language and the technology agnostic because each team is working on their own domains, so they can pick and choose whatever technology best fit for the purpose. For example, if there is one order related team, then they can choose to go with the stack of, let's say, the Java technologies such as Spring, Spring Boot, Spring Cloud. And then there is another team which is on the analytics side of the business, and they are working with large set of data and they are doing the analytics. Then they can probably use to go with the R, which is a language mostly used for the analytics projects. So this particular benefit comes only for the microservices that cannot be easily achieved for the monolithic application. Again, this is future proofing, faster time to market. We already discussed this little bit with the first point, because the application can be changed very quickly because they are decomposed into smaller and more manageable components, services. So if in future there is a need to do it differently, then that's totally doable. There is no big cost. Whereas the return on investment for the microservice is very high because you can always reuse or repurpose those services for future functionality as well. And the next one is the increased resiliency and rapid growth facilitation. Again, for example, let's take an example of Amazon. And then we have the COVID these days. So what happens is, I don't know if you are following the news, but the business for Amazon has, or not the main business, but the profit has grown manifold. So what happened is that in many areas there are lockdown situations, so people are not allowed to go and do the shopping for non-essential products. So the only choice left with them is to go online and do the shopping. Now, like as most of us, we do the shopping with let's say Amazon. So they got the increased business, which is caused something like rapid growth, and because Amazon is fully based on the microservices as well, so the basic infrastructure was in place to scale it up. Which we already discussed in the horizontal scaling, that they can increase their services to support a larger number of online clients. So the application is resilience is there, they and it supports the rapid growth as well. So these are few of the many advantages which microservice architecture will bring to your applications. So let's have a comparison of monolithic versus microservices at this stage. All the benefits of microservices outweigh challenges discussed above. Choosing microservices architecture enable organizations to be agile and implement DevOps, thus gaining technical or technological advantage over its competition. which is very, very important for any organization because this is time of digital and all the users are extremely tech savvy. So let's say in coming days and months, there will be new generation who will probably not wait for days or weeks for their mortgage approval. Rather, they want to have something processed very quickly for banks from banks. So the easiest way to implement those kind of system is to start moving, if not already, to microservices architecture. Over long term, cost to maintain technology stack will remain low because there are always different ways how you can monitor your cost. You can improve on your technology, or you can stop services when not required. So you are not basically um, uh, have to keep spending a fixed amount for keeping your services up and running. You can, based on the stats, you can make decisions on the fly. While discussing microservices, it is important to discuss gap theorem. As the theorem states that network shared data systems can only guarantee two of following: consistency, availability, or partition tolerant. So talking about consistency, I guarantee that every node in a distributed cluster will return most recent same successful write. And availability, every available node will return a response in a reasonable amount of time. And partition tolerant, this is a guarantee that system will continue to function with consistency in spite of network partition. Now, you can pick only two categories. Think of eventual consistent for your microservices. So this diagram shows like what kind of categories, a combination of categories you can choose. You can choose consistency and availability, and then you have to sacrifice on the partition. A typical database implementation for that is the RDMS. If there's network problem, then your application might not be available. A typical example of this is Oracle or MySQL databases. Or you can use availability and partition over consistency. That might introduce a read inconsistent data. A typical example of this might be AWS InnoDB. But at any given time, the client might see inconsistent data, but they will be eventually consistent. Or you can choose consistency and partition tolerance. In that particular case, which is CP category, some data might become unavailable, and but the rest of the data is still available, a subset of that data. So MongoDB is one of the typical example of this one. Containerization of microservice application. Now we have microservice architecture for our application, which is great, but then we need to also think about using containers. Because developing apps today requires so much more than just writing codes. Um, our services might be supporting multiple languages, frameworks, and within those frameworks, there might be different architectures. And discontinuous interface between tools, for each life cycle stage creates enormous complexity. So Docker simplifies and accelerate your workflow while giving developers the freedom to innovate with their choice of tools, application stacks, and deployment. We already talked about most of those things. So this slide actually shows you the same application with a little bit simplified version from the just focus on the microservices along with the container. So so this is these two different hosts. One host, we have the databases. So basically what happens in the Docker is that you have the build images available. That is in your image repository. One of those is Docker Hub. So you have MySQL image, and then you can spin three different databases from that one. And then they are these three different databases are running on within the Docker containers on a given host. And then we have the images for our own microservices, customer service image, we have the order service image, and we have the product service image. And these images are a snapshot at any given time. These cannot be modified once built, so these are immutable. We can start those services within the Docker container on any host. Now, this could be AWS Cloud, this could be Google Cloud Platform, or Azure. This could be choice of whatever cloud, or it could be a private cloud as well. So what will happen is that there is a Docker file, which will, using the build, we'll build the Docker images, and then we will deploy those images using the Docker containers. We can also use Kubernetes because Kubernetes will provide us different tools to support these deployments. Kubernetes is a portable, extensible open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. Kubernetes has a large, rapidly growing ecosystem. So, as like Kubernetes services, ports, and tools are widely available. I have a video about how to use Kubernetes on Google Cloud Platform. I will put the link for that down below in the description. Please have a look on that as well. Because the purpose of our today's presentation is not about Kubernetes, but just to give you an overview that how things can be simplified using Kubernetes, which is also known as K8s, and Docker and containers. So all those new cool things will make your life super easy. And while working with Kubernetes, we can use Ansible to script our environment that will provide us benefit of configuring the environments. So Ansible has a concept of playbook, playbook is a blueprint of automation tasks which are complex IT actions executed with limited or no human involvement. Ansible playbooks are executed on a set, group, or classification of hosts, which together make up an Ansible inventory. So it's a very cool thing. The biggest benefit of Ansible is that it doesn't need to be installed on all the machines. So where we have our let's say Kubernetes cluster. So that's a very cool thing. If I will post presentation on Kubernetes in coming days as well. Okay, so now time for conclusion. All the benefits of microservices, agile, and containerization outweigh challenges and efforts for sure. Now, some organizations are choosing to start from scratch versus others are choosing lift and shift approach. For migration, the features from monolithic applications are shifted to a microservices-based target application. Um, So the key is that we need to understand the business, and we need to understand what is the differentiator, what is our competition, where are we are heading to, and then we have to understand the our organization, what are our organization constraints, and how or where we stand along with the directions from the enterprise architect's office or the executives. But based on that, any organizations should take this approach to move to microservices based architecture. Thank you very much for being with us, and we hope that you enjoy the presentation. Catch you later.